Open/closed principal, OCP software entities should be open for extension, but closed for modification, allowing new functionality to be added without altering existing code.
So open close principle OC. So it means software entity, your classes or your module should be open for extension but closed for modification. What does this mean? Is like we have code, say we have code, so where existing code which the wrong one like violating OCP. We have a class of payment processor. The payment processor simply have a function. It takes type as a string, amount have double. So process payment it depends on different type, right? Like credit card, PayPal, crypto, and it has an amount two parameters. So it switch one the different type. If its type is credit card and it goes to the function process credit card and pass the parameter of amount. And if it's PayPal, it goes to process PayPal function process PayPal. And if it's crypto, it says goes to the function crypto. And your class, your software entity of this class of payment processor, if there's additional Apple Pay requires more, if you have additional payment method of Apple Pay, then you require modifying this class and saying Apple Pay processing Apple Pay amount. So you are touching the existing code, you're doing modification, and so each time you say if you add Apple Pay, you put your code Apple Pay over here, and if you get Google Pay, you get your code in the switch. You got Google Pay over here, and you put the code over here. This is your class of payment processor. So this will every time you add the new method, it will just modifying the class of a payment processor, and you need to redo the unit tests every time for this existing class, and if you have a team like your class, yeah, you have package of this for this payment process class, and if different person working on this same class, you can have conflicts. So the principle is simple, like software entity, your class or module or any entity should be open the door. You should open the door for extension. Extension is welcome, and but close the door for modification. If you modification for the existing entity, let's close the door and not welcome. So the right way. So how can you just make the right way? Is you are using interface. So you abstract this function, like you create an interface of payment method. So using the interface, and anytime you add a new payment method, you can just inherit that interface, get implementation of a new interface, and your payment processors, functional process payment, access parameter of the method, which is type of the interface, and your newly added payment method, which will implement the interface. So using the interface implementation of interfaces, new payment method is just extend your existing class of a payment processor without modifying the existing code. Your function will process payment and access the new payment method, which is a type of interface of payment method. And this part of your class of payment processor will never change, and you don't need to redo the unit tests. And the newly added implementation of the interface of the payment method, for example, like Google Pay, your new code it's an extension, it's the implementation of the interface, but it's attention it's just accepted by the class, your payment process class. It's just as a parameter, and newly added class, so it's isolated from any existing code. It's an extension and your Google payment. So any your code you can do in the unit test for the newly extension and will not affect any existing code. So you can do any just type of new extension like you can say Visa Pay, whatever your newly added payment method will never affect the existing code. So any new extension, you just do the unit test for the new extension, and your new code is isolated from the existing code. If there's a and it will not be a conflict with existing code. That's why your software unity should be open for extension but closed for modification. So you can see if you run the application, say we got a payment processor and payment process, we got Apple Pay, and we say processing Apple Pay and the amount of it. I say processing Apple Pay and the amount is this amount, $100, and so you can see the benefits of OCP. OC is you reduce the risk. So you newly added attention code will not touch the working code. So if say your existing code over there and the newly added code will not touch the existing working code, so will be fewer bugs introduced. And easy extension is a new feature without modifying existing code, so you can simply implement the interface, and that will be a new feature without modifying existing code. And better testing, so existing testing remain valid. So any existing testing will remain valid. Only the newer added attention code need to be new unit testing. And multiple developer can add new feature independently, so they can work on different new implementation of the same interface. And each developer have their can work on their own code. And maintainability, so easier to understand this type of working to implementation of the interface is easy to understand, debug, and extend over time. So if you put everything in the code, everything just inside your class, when the code grows, and this will be very complicated. If you put it into the separate implementation, then that will be easier to read and understand. And the real world example, like Android views, like text view, button, and this Android view is extended view. Everything is a view in Android without modifying the view class at the UI, right? And the strategy pattern, this is one of the real world example. The plugin system like Visual Studio Code extensions. This is using the open close principle. And like notification system, very popular, like different notification method like email, like text message, push notification, all implement a notifier. And shape drawing, like different shape, it turns the shape class.